Hi there. This video is to get you prepared for a detailed case study for Lady Elliot Island for one of the two case studies that you've got used for ecosystems at risk. Let's have a look about what the syllabus says about the case studies and what you've got to know and include. So you've got to know the spatial patterns and dimensions, the biophysical interactions, the nature and rate of change which affects ecosystem functioning, human impacts which are both positive and negative, and then traditional and contemporary management strategies. So what I've done, each part of those dot points I've covered in this PowerPoint, and I'm just going to quickly go through the information so you've got that detailed knowledge for when you come to revise, and then these are the case studies you'll use in extended responses. So we're going to look at Lady Elliot Island first. So let's start off with the spatial patterns dimensions. So it's located 80 kilometres east of Hervey Bay in Queensland. The altitude obviously goes from sea level because it's an island to about 8 metres above sea level. It's very small. The latitude is 24 degrees south of the equator. It's just in the tropics, and the size is 45 hectares. The shape, it's a teardrop in shape, and that's due to the coral cave formation, which we'll talk about later on. And continuity, it's not on its own, it's actually part of the Great Barrier Reef, and obviously the material for it to form was from other corals as well. So that's where that continuity comes in. It's part of a bigger ecosystem. Okay, so the biophysical interactions that happen at Lady Elliot Island, we're going to look at the dynamics of weather and climate. So first of all, climate, and obviously we're looking at climate change, whether human induced or natural. Any increases in the sea level would mean that the island would become inundated by the sea, and that would have huge effects on the coral formations and also the habitats that are used by fish and other species of animals and plants that live on the algae. So you've got to remember, Lady Elliot Island being a reef needs shallow warm water for it to function. So if the seas become higher and the sea levels deeper, then that's going to affect their functioning. Because the Great Barrier Reef as well as Lady Elliot Island are just in the tropics, they suffer from severe and tropical storms. The movement of the water in these storms can really damage the coral, just like in a river when we've got rocks being picked up by the river. Well, that can happen with wind and the rough seas when we have a severe storm. So they're two things that with the interaction of weather and climate can have a negative as well as positive effect on Lady Elliot Island. After storms, when we've got lots of coral being broken up, that is obviously material that other species of plants and fish can use to eat, so it's a source of food. And then obviously it's material that can be eroded and weathered away to form more coral caves in other places. That leads me on nicely to the geomorphic and hydrological processes. So geomorphic is the movement of the land, and then hydraulics the process of water. And you might be thinking, well, how can we have the movement of land when we're 80 kilometres from the mainland of Australia? Well, you've got to remember that the Great Barrier Reef is old parts of mainland Australia that have obviously been flooded. In the last sort of ice age around 30,000 years ago, that would have been land where people used to live on. Because of the ice melting from the last ice age, sea levels have risen, and as a result we've got those shallow areas of the Great Barrier Reef, which has obviously led to the formation of the Great Barrier Reef. And as a result we've got lots of material that can form these coral caves. Now, a coral cave is just a huge amount of broken up coral that has formed in a particular place, and because of currents, it keeps piling that debris into a big pile, and over time that pile gets bigger and bigger, and it starts off at the bottom of the ocean and then gradually rises up. And that's what's happened at Lady Elliot Island, and that's why it's called a coral cay. It's a build-up of material, and as a result, once the material's got so high, it's pushed through the sea surface, and then we've got an exposed island, and then because of it being exposed to air, and it's become, you know, a body of land, we've got the formation of soil, and that's been helped by lots of seabirds. So seabirds, obviously they spend a lot of their time out to sea, and when they see an island, it's a good place to stop. And as a result, the birds stop maybe for a long period of time, short period of time. And what do they do best? Well, after a long time, birds obviously poo, and then that lands on the ground for a long period of time. All that you know, bird feces then forms and breaks down into nutrients, and that's how we get soil. Within the bird's feces, they would have eaten seeds, and then we've got the formation of basic vegetation, and we'll come back to that vegetation in the next part. Once we've got that bird feces, we get a process called guano. That guano is a mixture of you know, material and birds, any other stuff that gets washed away, and that's where we get that forming of soil. So the soil on Lady Elliot Island, it's not, there's no sort of sand, it's broken down coral and then a mixture of bird poo. I put their guano mining. Humans, when it was discovered in the mid-1850s, people came to Lady Elliot Island and mined the guano, and that guano was then used in the production of gunpowder. So it was, you know, quite important. There was a high phosphate level, and that's what we can use to make gunpowder. So when we're talking about geomorphic and hydrological processes, we've got that movement of the water that brought all that debris of dead coral, and that built up to form an island. That island then has formed soil, which has then led to the formation of vegetation. We do have some shrubs and then trees as well. And then we had guano mining, which took away that level of soil. With the biogeographical processes, we're talking about vegetation. Now, I've already said that coral cay would have been this bare bit of coral that poked up from the sea, and over time birds had come there, and as a result we've got this invasion of vegetation that probably wasn't meant to be there. So we've got seeds come from the mainland of Australia and then planted there, and we have some basic shrubs there, and then they've come to live there, and then from the shrubs you get, you know, sort of grasses, that type of thing, and then as time goes on, those shrubs turn into trees, and that's where we get that succession of different plants, and then those plants have modified themselves to live on the island, and they've built up a resilience. And just with the nature of change, obviously anything to do with natural change is a slow process. So animals and plants, because of, and this is where we go back to vulnerability, resilience, and magnitude of change, they can cope with that change, whereas anything that's human change obviously is very quick, and therefore ecosystems can't cope with the rate of change. Obviously with natural change we do have catastrophic events such as volcanoes, earthquakes, tsunamis, and if a tsunami happened you know, Lady Elliot Island, there would be a some widespread damage, and it wouldn't matter if the resilience was very high. These things happen, but they're very, very rare. Human impacts are, quite common, particularly now, and that's some of the biggest problems that ecosystems at risk face. Okay, moving on to human impacts, we got positive and negative. In your question, you might be asked what the positive as well as negative are, so it's always important to remember that positive. We'll start with the negative. So Lady Elliot Island was actually used for mining, as I've said before, for guano, which is a type of substance used for gunpowder, and as a result they took something like 5 meters of soil, and along with the soil took any vegetation that grew there. There's actually only 5 trees left there from the original time. A lot of the vegetation has been replanted, which on the flip side is a positive, because we've turned it into a protective ecosystem and reintroduced some of those species that we'd lost. It was used, and it still is, as a lighthouse, but obviously we've improved the technology there. That it's a negative reason because it might affect the turtles that live there. When they're born, they rely on the natural light of the moonlight, and any extra light from extra light sources could make the turtles lose their way to the sea. So that's negative, but we do what we've seen now, we've seen technology improve, and the light obviously doesn't shine that part of the island where there's turtles. It used to be that a generator for electricity was used, diesel generator, which obviously gives out fumes, and that used to run 24 hours a day. However, now they've moved to solar panels. And then obviously boat activity is not very good for the Great Barrier Reef, because boats, what they do, they hit the reef and can break and damage the reef, as well as upset any animals there as well. So there's some of the negative issues, but on a whole, Lady Elliot Island is a really positive example of good ecosystem management. We've got law that protects the ecosystem, so we can't have big ships going near it. We're not allowed to fish there, which helps all the fish species, sort of keep going. It's an ecotourism resort, which means there's no large scale development there. Everything's very small scale. They limit the number of people who can visit every day. And what they've tried to do is minimize the human impact by using recycled water. They use solar panels as well to generate electricity, and obviously it's a source of education for guests, and more people who know about Lady Elliot Island and ecosystems at risk, the better, because they're going to change the way that they act. So they're the human impacts. And finally, when we look at management practices, we look at how we can obviously look after and protect ecosystem at risk. So Lady Elliot Island, there is no traditional management practices, because no indigenous people live there, or there's no evidence. But it's not to say that around the Queensland coast there isn't traditional management practices. The fact that indigenous people fished at certain times, only use what they can use in a sustainable way. There's plenty of middens there, which is a sign that fish was plentiful as well. And then obviously parts of the Queensland coast, they use plastic management as well. The contemporary management strategies are sort of outlined already. It's an ecotourism resort. They use as much recycling as possible. They minimise human negative impacts as well. So there's just heaps and heaps of contemporary management strategies. I hope that's given you a good outline of the management strategies used at Lady Elliot Island. I hope that gives you a good case study. You need to make sure you know this case study inside out, ready for the HSC exam. Okay, I hope that's given you lots of information. You make your Cornell notes, and that you answer the Google forms on the on Lady Elliot Island. Okay, thanks. Bye.